What if I told you there's a simple piece of paper under your hood right now that could be the reason your engine never makes it to 100,000 miles? Most drivers have no idea, but these air filter mistakes can quietly turn your engine into scrap metal without a single warning until it's far too late. While you're watching this, microscopic particles between 5 and 20 microns are either being stopped by your air filter or they're slipping past it. If they get through, they act like sandpaper grinding away at your piston rings and cylinder walls every time your engine turns over. You'll never see it happening, but the damage adds up with every mile. The most expensive air filter mistake on this list can destroy a turbocharged engine in months, not years. But before we get there, you need to see how the small mistakes quietly set you up for the catastrophic failures. Let's start with mistake number 13. This one sounds so basic that almost everyone gets it wrong. Mistake number 13 is leaving the plastic packaging on your air filter. You buy a new filter, rush through the install, and don't notice the wrapper is still on the element. You close everything up, start the engine, and suddenly it's running rough or stalling. You've just blocked your engine's ability to breathe. This happens more often than you'd think. Some air filters ship with heavy plastic protection to prevent damage during shipping, but if you leave it on, you're literally installing a wall instead of a filter. The engine immediately struggles because it can't pull enough air through the sealed plastic. On turbocharged engines, this is even more dangerous because the turbo tries to create massive suction trying to pull air through a completely blocked filter, which generates extreme vacuum that can damage seals, collapse intake hoses, or even pull oil past turbo seals. On vehicles with mass airflow sensors, a blocked air filter produces bizarre sensor readings because the MAF is trying to measure airflow that's nearly zero or coming through unintended gaps and leaks as the engine desperately searches for air. Before installing any air filter, take the extra 15 seconds to remove all packaging completely, check for directional arrows printed on the air filter frame, and hold it up to a light source to verify you can actually see through the filter media. That simple check prevents an embarrassing breakdown. But even if you remove the packaging correctly, mistake number 12 is something almost nobody does. Most people close the airbox, slam the hood, and drive off. That's a huge mistake because modern air filters are directional. Install one backward and filtration drops by 50%. Here's what separates the pros from everyone else. After installing your air filter, start the engine with the hood still open. Listen for hissing, which means a leak. Whistling means a gap. Rough idle means restricted airflow. Watch your dashboard for warning lights. Then take a 2-minute test drive with gentle acceleration, cruising, and a short throttle burst. This catches issues that only appear under load. If anything seems off, shut it down and double-check your work. This simple verification prevents thousands in damage. Now we're getting into problems that seem unrelated to the filter, but happen during every service. Mistake number 11 is loose connections and failed temporary fixes. When you close up the airbox, loose clamps on the intake tube let unmetered air into your engine. The ECU can't add the right fuel amount, causing lean conditions, rough idle, and hesitation. You'll hear hissing that changes with throttle because fast-moving air through gaps creates turbulence. The MAF sensor connector also gets bumped during service, causing erratic readings. Before closing the hood, check every clamp for tightness and make sure the MAF connector clicks firmly. Here's the other part. If you discover a cracked intake boot and patch it with duct tape or silicone, intending to replace it later, you're setting yourself up for disaster. Tape and adhesives break down under engine heat. Pieces get sucked into the engine, wrap around throttle blades, or stick to MAF elements, ruining their calibration. Intake boots cost $30 to $80 and take 15 minutes to replace. There's no excuse for temporary fixes that can cause catastrophic damage. Let's talk about the biggest cause of unfiltered air entering your engine. Mistake number 10 is compromised seals and bypass routes. Your air filter only works if all the air goes through it, but cracks in the airbox, poor gasket seals, and gaps around the filter let air take the path of least resistance, making even premium filters useless. Airbox housings and intake boots face constant heat cycling, vibration, and chemical exposure. Over time, plastics become brittle and rubber hardens, then cracks. These failures start at stress points like mounting tabs, corners, and bends. Heat cycling causes permanent embrittlement that can't be reversed. A common mistake that tears boots instantly is lifting the airbox without first loosening the connection at the throttle body. The filter gasket must also seal evenly. If you install it crooked or force one side closed before the other, gaps form. Square-cornered aftermarket gaskets in rounded housings leave triangular gaps at corners. During every air filter service, inspect airbox corners and mounting tabs for cracks. Check boots at bends and clamps for splits, and run your finger around the gasket after air filter installation to verify even compression. If you see dirt on both sides of a crack, air is passing through. Small cracks grow over time. Address them immediately, because the component costs $50 to $200, while contamination damage costs thousands. Here's one that happens during installation, but gets completely overlooked. Mistake number 9 is contaminating your new air filter before you even start the engine. When you remove the old dirty filter, dirt falls into the airbox or onto sealing surfaces. The airbox gets dusty over time, especially around the gasket area. Installing a new air filter against a dirty surface creates a bad seal and transfers contamination. When you start the engine, loose debris gets sucked into the intake. Before installing a new air filter, take 60 seconds to clean the airbox interior. Focus on the sealing lip, the floor where dirt settles, and any internal baffles. Use a clean rag for sealing surfaces and vacuum loose debris. Don't blow it out with compressed air, because that redistributes dirt into places it'll get sucked into the intake. Now we need to address what happens when problems do appear. Mistake number 8 is ignoring the warning signs your engine is screaming at you. When problems show up right after maintenance, that service almost always caused it, but people ignore symptoms or think it's coincidence. Code P0101 for mass airflow problems is extremely common after filter service, usually from sensor contamination or intake leaks letting in unmetered air. Instead of checking, people replace the sensor. Use a scan tool to watch live data and airflow readings in real time. Verify the MAF responds to throttle inputs, check for visible contamination, and inspect all connections. This diagnosis costs nothing and saves hundreds in wrong parts. Pay attention to specific signals. Rough idle or hesitation after filter service means an installation error like a backwards filter, packaging still on, poor seal, or bumped sensor. Hissing indicates vacuum leaks. Whistling indicates gaps. Performance loss happens so gradually that drivers adapt unconsciously, only noticing the difference when the problem is finally fixed. Let's talk about a money-saving attempt that backfires. Mistake number 7 is blowing out paper filters with compressed air to reuse them. Automotive paper filters use delicate fibers to trap particles. When you hit them with compressed air, you damage those fibers and create holes that let dirt pass straight through. Blowing from the dirty side pushes embedded particles deeper into the media, rupturing the fiber structure. The filter is designed as a one-way barrier. Once particles are trapped, forcing air backward creates permanent channels for contamination. Paper filters are disposable by design. When they're full, replace them. The cost of a new filter is nothing compared to cylinder scoring and turbo damage from a compromised filter. This next mistake creates a chain reaction of expensive problems that most people completely misdiagnose. Mistake number 6 is the complete over-oiling and MAF contamination cycle. Oiled cotton gauze filters work through a combination of the cotton weave capturing particles and an oil film that makes particles stick to the fibers. The oil should create a thin, tacky film, not saturation. But the common error is applying oil until the filter is visibly wet or actually dripping oil. Users think more oil means better filtration, but the opposite is true. Excess oil gets carried downstream by high-velocity airflow into the airbox where it pools, then through intake piping, and eventually onto the MAF sensor, where it coats the delicate heated elements. The MAF works by maintaining a heated wire or film at a precise temperature and measuring the electrical current required to maintain that temperature as cooling air flows past. When oil coats those elements, it acts as thermal insulation, changing how heat transfers from the element to the airflow and producing incorrect airflow readings. This causes the ECU to calculate completely wrong fuel delivery amounts, resulting in rough idle, hesitation, stalling, poor throttle response, and P0101 diagnostic codes. Here's where it gets expensive and frustrating. A check engine light appears, and most people just replace the sensor for $200 to $400. The problem disappears for maybe 2 weeks, then returns because the contamination source was never addressed. The cycle repeats and money gets wasted. method. Instead, use dedicated MAF sensor cleaner spray that costs just a few dollars. Spray from about 6 to 8 inches away, never touch the hair-thin sensing elements with anything, and let it air dry completely. These elements are thinner than human hair, and touching them with fingers, rags, or brushes will bend or break the wires or deposit oils that ruin calibration. But cleaning the sensor is only half the solution. You absolutely must fix the contamination source. When applying oil to the filter, use only the measured amount specified by the manufacturer, typically just a few ounces for a complete element. Apply it in thin, even passes while rotating the air filter to ensure all surfaces get coverage without creating puddles or drips. Then let it cure overnight so the oil can redistribute through the cotton fibers via capillary action, and the carrier solvents can evaporate. Curing doesn't mean the oil dries solid. It should remain tacky, but the excess mobile oil stabilizes and won't migrate as easily. If you rush the process, you risk problems. Installing the air filter while it's still wet makes it worse. Then, if you drive aggressively with high throttle, airflow increases rapidly. That pushes the oil straight into the intake at a much faster rate. The MAF sensor is typically located very close to the air filter and easily accessible during routine filter changes, so make it a standard practice to visually inspect the sensor whenever you service the air filter. You can often see oil contamination just by looking at the sensing element. Catching it early and cleaning it proactively prevents bigger drivability problems and saves you from the expensive misdiagnosis and replacement cycle. And remember, never use brake cleaner, carburetor cleaner, or throttle body cleaner on MAF sensors, because the harsh solvents in these products will attack protective coatings or leave residues that permanently alter sensor characteristics. Now let's address service intervals. Mistake number 5 is following your owner's manual without thinking about your actual conditions. Manuals specify 15 to 30,000 mile intervals, assuming clean roads and ideal conditions. If you drive in dust, on gravel, in construction zones, or harsh environments, your filter clogs much faster. A clogged filter doesn't just reduce power. Severe restriction increases intake vacuum, stresses components, and on turbocharged engines creates underboost conditions. Some people go even further and never replace disposable air filters at all. They drive 50 to 70,000 miles on the same filter. Once clogged, air filters either force particles through damaged areas or restrict airflow until the engine struggles. Severely clogged air filters look dark gray or black with collapsed pleats. Performance loss happens so gradually that drivers don't notice until replacement, when suddenly throttle response, acceleration, and fuel economy all improve. Here's your test. Hold the filter to bright light. If little or no light passes through, replace it regardless of mileage. People in dusty areas need changes every 3 to 6,000 miles, not 15 to 30,000. A filter costs $20 to $60. Cylinder scoring and compression loss cost thousands. Keep a spare on hand to eliminate procrastination. We're now into systems level thinking. Mistake number 4 is treating the filter as an isolated part instead of understanding it's part of a complete system. The air filter works with the airbox, intake hoses, sensors, crankcase ventilation, and all connections. Over-oiled filters coat sensors even though the filter itself is clean. Poorly fitted air filters let air bypass even with premium media. Cracked airboxes defeat the best filters. If your PCV system dumps oil into the intake, the air filter can't stop it. This is especially critical on turbocharged engines where consequences multiply. The same particles that cause gradual cylinder wear over 50,000 miles in a naturally aspirated engine destroy a turbo in 10,000 miles because they're accelerated through the compressor wheel at over 100,000 RPM. During air filter service, verify the entire system. Is the airbox intact? Are connections tight? Is the filter sealed? Is the PCV functioning? Are boots and hoses in good condition? Are sensors clean and connected? Check every component because your filter only protects when the whole system works together. Here's a controversial one that affects enthusiasts. Mistake number 3 is removing factory protections with aftermarket intakes. Aftermarket cold air intakes promise horsepower and sound, but removing the factory airbox loses engineered protections. Factory airboxes include baffles and flow straighteners that present smooth laminar flow to the MAF sensor. The sensor is calibrated for this conditioned flow. Open air filters or straight tubes introduce turbulence that creates velocity variations across the sensing element, producing reading errors. Check engine lights with MAF codes are extremely common after aftermarket air intake installation. Water ingestion is another serious risk. Aftermarket intakes often place filters low near wheel wells, where water gets sucked in during heavy rain or puddles. Hydrolock happens when water enters the combustion chamber. Water doesn't compress, so the piston tries to compress an incompressible liquid, instantly bending rods, cracking pistons, or damaging heads. 1 second destroys the engine. Open intakes also pull hot air from the engine bay, reducing power and increasing knock risk, especially on turbos. Factory intakes are shielded and draw from cool locations. Performance gains are minimal, typically 5 to 10 horsepower, while risks are very real. Many return to stock after dealing with contamination, water damage, and heat soak. Now we're at the serious internal problems. Mistake number 2 is ignoring oil contamination from crankcase issues. If you see oil in your airbox, it traveled through the crankcase ventilation system, and there are 3 main causes. First, the PCV valve and hoses. The valve meters flow and prevents backflow, but when it sticks or hoses crack, oil vapor coats your intake and sensors. Check by removing the valve and shaking it. If it rattles, it's working. No rattle means it's stuck. Replace the valve for $10 to $30 and inspect hoses for cracks. Second, turbocharged engines face boost, pressurizing the crankcase. In naturally aspirated engines, intake manifold vacuum pulls crankcase gases out, but turbo boost creates positive pressure that pushes oil vapor backward when there's no check valve. If oil appears mainly after hard driving or boost, not gentle cruising, boost is forcing oil into the intake. Install check valves or an oil catch can for under $200. Third, excessive blowby from worn piston rings or cylinders. In healthy engines, blowby is minimal. As rings wear, combustion gases escape into the crankcase until the system can't keep up. You'll see oil-saturated filters despite PCV maintenance, oil pooling in the airbox, frothy oil in piping, and oil levels rising between changes. A compression test confirms the problem, but the fix is an engine rebuild costing thousands. Catching these issues during filter service prevents contamination cycles and expensive sensor replacements. And now, the #1 most catastrophic mistake. Turbocharged engines magnify every filtration failure because the turbo spins at 80,000 to 200,000 RPM. Even tiny dirt particles hit the precision-machined aluminum or titanium compressor blades at velocities approaching the speed of sound at blade tips. The kinetic energy erodes material exactly like sandblasting. Erosion starts as light pitting on leading edges, then deepens and rounds blade profiles, degrading aerodynamic efficiency. The compressor must spin faster for the same boost, increasing mechanical stress and bearing temperatures. Eventually, it can't reach boost targets or creates mass imbalance that sends metal shavings into bearings. When dirt gets into the bearings, the wear changes from normal sliding to something much worse. Those tiny hard particles get trapped between moving parts and act like grinding sand. Instead of surfaces gliding smoothly, they scrape and cut into each other with every rotation. As the metal wears away, the space inside the bearing grows larger. This extra space lets the shaft wobble and vibrate, which makes everything wear even faster. The more it moves, the more it destroys itself. Eventually, the bearings can't support the shaft anymore. They either lock up or break apart, and when that happens, the turbo doesn't just stop. It destroys itself while spinning at over 100,000 RPM. The compressor blades can hit the housing, sending metal pieces into the engine's air system. At that point, the damage is so severe that repairing it usually costs more than replacing the entire turbo, and sometimes even hurts the engine. A new turbocharger will cost you anywhere from $1,000 to $5,000, and that's before you even pay for labor. Even a really clogged air filter can completely destroy your turbo. It creates this extreme vacuum at the inlet that puts huge stress on the bearings, and actually sucks oil past the seals where it shouldn't go. When the airflow gets restricted, the compressor has to spin way faster to keep up. This can push the system into something called surge. That's when the air actually flows backward, creating these mechanical shocks that can crack the turbo wheels. Now, in regular engines without turbos, the same dirt problem happens differently. The contamination causes gradual wear on the cylinders and piston rings over tens of thousands of miles. These tiny particles get trapped between the rings and cylinder walls. They act like grinding paste, slowly polishing away the crosshatch pattern. Once that pattern is gone, the engine can't hold oil properly and loses compression. You'll notice symptoms like harder starting, a rough idle, and misfires. If you check your oil analysis, you'll see rising levels of silicon and metal particles. Here's the bottom line. Air filtration is about protecting your entire engine, not just swapping a part. Inspect, clean, and seal every connection, and fix issues right away. Waiting for warning lights is almost always too late. If you want your car to last well beyond 100,000 miles, never overlook the small details. But here's something most drivers miss. Air filter mistakes are just one piece of the puzzle. There are 18 everyday driving habits that are secretly killing your car, and most people have no idea. Click here to find out what they are before it's too late.